I lost to friction. So I'm going to start with a free body diagram here. Just reading the question, it kind of implies that my applied force of 200 is less, unfortunately, than the friction. So the friction is going to beat me. I'm going to lose to it. And that means that the box is going to end up coming to a stop. The friction is slowing it down. There's going to be gravity and normal as well, which are going to be balanced to each other in this case. Okay, so I have to find a time at the end of the day. That is what they ask here. So time is a kinematics quantity, probably going to come from the big five. So let's start listing things that I have in terms of kinematics. Let's start a heading over here. So I have to find the time. I see that I start with a velocity of 5. This box is going to come to a stop, so the V2 will be 0. So no displacement is given here. 0.30 is given as the coefficient of friction. That's not a kinematics thing. So that's all I'm given in terms of kinematics. I'm given these two numbers. You probably, well, hopefully you know by now that's not enough to solve for the time. I need to figure out one more value here first. That value is going to be the acceleration. Yeah, this is a theme happening over and over again. Acceleration is our connection. So I'm going to have a separate heading, which I'm going to work on first, and that's to find the acceleration. And I'm going to find the acceleration using Newton's laws. Because I cannot find it with the kinematic side. All right, so Newton's second law, F net equals ma. So F net stands for the net force or the overall force or the resultant force. After things have been canceled out or partially canceled out, how many newtons are left over and in which direction? That's the net force. So when I look at my free body diagram, I have gravity and normal canceling out. And then in terms of left and right, my friction arrow, since friction is going to beat me, friction is longer. So the net force is going to be however many newtons friction is, subtract however many newtons I apply, which I know is 200 actually. So that is my simplified expression for net force. It is the magnitude of the friction minus the magnitude of the applied. It's going to be a positive number. And due to Newton's second law, whatever that equals will equal to the mass times the acceleration. But now I'm putting magnitude bars around acceleration because this is really only going to be good to find the magnitude. I know my direction, it's going to be left. Just looking at the diagram, the direction is going to be left. But I have to write proper notation for mathematics. Okay, the force of friction. We are given this coefficient of friction here, so let's use that. The force of friction is equal to coefficient times the normal force. So that's going to be the only change I make for this step. And the normal force, the magnitude of the normal force, in this case, again, it's equal to the magnitude of the force of gravity. They are equal in magnitude, so I can replace the normal force with mg. So just scanning my equation here, something I like to do is see if I'm ready to substitute variables or not. And that's really going to depend on if I have all the values I need. So I'm trying to find acceleration. So do I know the values of everything else in this line? Do I know the mu? Yes. Do I know the mass? Yes, 100 kilograms. Do I know g? Yes, it's 9.8. Do I know the applied force magnitude? Yes, that's 200. And then mass again. So I'm actually good. I know all of those values, so I'm confident that I can solve for this acceleration. First, I'm going to divide both sides by the mass, just to get it totally isolated. Divide both sides by the mass. Now we'll fill in the values. Okay. Can I just cancel the masses? No. Because in the numerator there's two terms, and if I want to cancel the mass, both of those terms have to have mass to divide out. But when I fill in the numbers here, I'm actually given pretty nice numbers. Both of the terms in the numerator are divisible by 100, so I can actually divide them both by 100 to do this. So 200 divided by 100 is 2. Okay, so let's go 0.3 times 9.8. That'll be 29 point, no, that'll be 2.94. Subtract 2, giving me 0.94 meters per second squared. So that's the magnitude of the acceleration. Just based on the diagram, I know the direction is to the left. The direction is to the left. And this number is what I'm going to fill in my kinematics list here. It's going to be negative 0.94 meters per second squared forward. So my acceleration is backwards, so I make it negative forwards, so that I can match it with the forwards direction that I wrote for V1. Okay, so now I'm ready to solve for the time. Use the Big Five formula that has these variables in it. That would be the first one. Isolate this for time, which ends up being like this. And then sub in the values. So I have 0, subtract 5, divided by negative 0.94. So the signs look good. It looks like I'm going to have a negative divided by a negative, which will give me a positive answer, which makes sense for time. And this is giving me 5.3 seconds. Okay, so delta t equals 5.3 seconds. So what time is the end? 5.3 seconds. Okay, because it said that it started at t equals 0. So that's kind of important, and it can be a little tricky, maybe for some of the problem set questions that they might not actually start at t equals 0. So for example, if I said that it started at t equals 10, and we just calculated that delta t equals 5.3, then the ending time would actually be 15.3. So we just got to be careful sometimes. But for this question, like, this is the answer. The final time is 5.3 seconds.